And without further ado, I'd like to introduce Adrian McNeil and Esther One from Foxglove Studio, or talking about Foxglove Studio, imagining the next generation of ROS visualization. Adrian and Esther, please take it away.
Hi, thanks, Tully. And yeah, as Tully mentioned, our talk is imagining the next generation of ROS visualization. Just a quick background. So I'm Adrian McNeil, the CEO and co-founder at Foxglove. Prior to founding Foxglove, I spent 5 years leading the developer tools and infrastructure group at Cruise.
And I'm Esther, community manager and technical writer here at Foxglove. I also previously worked at Cruise as a software engineer on the Webvis team, which Adrian will talk a little bit more about.
So before we get into it, I just want to talk quickly about why visualization is important in the field of robotics. Debugging robots is really different from traditional software development. So when you're building traditional software, it's really easy to just add breakpoints or print statements to see what your app's doing. But when we're building robots, we have these much more complex behavior emerging from the combination of machine learning, algorithms, and hardware. And we need an understanding of how a robot perceives and interacts with the world. This is much easier for a human to do visually because we can just check sensor input to see if there's mud on our camera. We can look at our tracked and classified objects to check for mistakes, and we can render our planned actions and see if they match our expectations. The current tools in the space have served us well so far, but I think that there is room for improvement. So for example, today, visualizing a single robot often requires you to open multiple tools and windows to rearrange them on your desktop. Often these tools are not cross-platform and they don't have any built-in way to share data among team members. And finally, the tools are often tightly coupled with a particular framework. So for example, there are different versions of ROS for ROS 1 and ROS 2, and they require you to have ROS installed and running on that computer to even open. And I can't just connect to a single sensor and just check its, verify its output. At Cruise, we saw these pain points and we built a tool to solve them. So around 2017, we started this project called Webviz. We went around all of the engineering teams at Cruise asking which tools they currently use and any pain points with them. And we built a single app to solve all of these pain points. We decided really early on to make it a browser-based app. So the web has become a really mature platform over the past decade, and we have all of these great technologies now like WebGL and WebAssembly that allow us to build really high-performing apps. By building a web app, we can make it cross-platform, and we can make it easy for anyone at the company to access, from our hardware engineers to software engineers, vehicle technicians, quality assurance, all of these people working from a single source of the truth. Now, this project was a huge success at Cruise, and in 2019, we decided to open source it. Some of our team members actually were at ROSCON 2 years ago in 2019 to demo it. And Webviz got a lot of traction in the community and a lot of good feedback. But unfortunately, a lot of the Webviz code is still really tightly coupled with internal systems at Cruise. Anyone that's tried to use it might have noticed that. And so that means that several great features that exist at Cruise never made it into the open source version. And it also means that it's quite hard to contribute to as an open source project. And so because of this, Webviz has many outstanding bug reports and feature requests, and we felt that we could improve that. And so that brings me to Foxglove. Foxglove was founded at the beginning of this year, and our mission is to make it easier and faster for robotics companies and organizations to bring your robots to market. And so we have two products right now. Foxglove Studio, that we're talking about today, is our open source visualization platform. And we see Foxglove Studio as the next generation of robotics visualization. So not just a replacement for Webviz or RViz, but an extensible tool and a platform that you can use as a base for all of your development and visualization needs. We also just announced a new product this week, actually, the Foxglove Data Platform. So this is brand new, and I'll talk a little bit more about it at the end if we get time. But basically, this allows you to upload your bag files or other robotics data to the cloud, organize, tag, and search the data, and then easily access and stream your data from anywhere. So now I'm going to hand over to Esther to talk more about Foxglove Studio and give you a demo.
Awesome. So when we started Foxglove, we wanted to go back to the drawing board and really reconsider what the next generation of ROS visualization could look like. So we asked ourselves some of these following questions to get back to the basics of what we needed to build. So for example, what hinders ROS developers today? What was difficult or inconvenient for them to do currently? and what were they unable to do at all? And how could teams of roboticists collaborate more effectively? And what would a next generation tool look like if we could completely reimagine it, not just build on top of the workflows that we've gotten used to? And so we wanted the answers to these questions to guide our strategy going forward. First and foremost, we decided that we wanted the tool we built to be accessible to anyone. So we're maintaining Foxglove Studio as an open source project, so we can collaborate with the whole robotics community, not just by asking for your contributions, but by also shaping our roadmap around your requests and use cases. So whether you're a casual hobbyist, a researcher in a lab, or an engineer at a global robotics company, you should be able to use Foxglove Studio and also have a say in how it evolves. We also wanted to provide a single integrated development environment that will make it easy for newcomers and experts alike to get up and running. So we didn't want to provide a long list of tools that you would need to find, install, and then learn how to use. Our goal was to collect everything that you would need in one convenient package, and then allow you to easily contribute to that ecosystem and extend it depending on your specific use cases. Next, we wanted our tool to be as flexible and customizable as possible so that it could evolve with the industry and your own changing needs. To that end, we released Foxglove Studio as both a desktop app and a web app. The desktop app is available on Mac OS, Linux, and Windows. Both apps support a variety of data sources and connections like ROS1, ROS2, ROS Bridge WebSocket connections, local and remote back files, and more. We also wanted to make it easy for you to customize Foxglove Studio to work for your team. So you can choose from our suite of available configurable panels and use those to compose unique layouts. And then you can share these layouts with your teammates. You can write custom data transformations to analyze your data. And you can even build your own panel as an extension if what Foxglove Studio offers out of the box isn't sufficient for your workflow. And of course, as an open source project, Foxglove Studio can always be modified to your most unique specifications. And lastly, we wanted our tool to be scalable. We wanted even the largest robotics teams to be able to benefit from its features. We knew from past experience working on larger teams comes with its own unique set of challenges. And so we wanted to tackle those head on from the beginning. Remote data storage was one of those challenges that came up consistently. We knew that without having reliable remote storage, teams often have to jump through a lot of unnecessary hoops throughout development. Earlier this month, actually, we released cloud synced layouts, so you can save and sync your debugging workspaces across all of your devices and just make your development process that much more seamless. We also wanted to make collaboration more efficient. And so we expanded on those cloud synced layouts to make it possible to share those layouts with your teammates with a single click. We also added support for streaming data from remote sources like Amazon S3 or Foxglove Data Platform, like Adrian mentioned, because we believe that visualizing your data with a particular layout should be as easy as clicking or sharing a link. And so Foxglove Studio, as it stands today, is the result of following these core tenets that we came up with. Since starting the project, we've made exciting progress in some new features. We've enabled native ROS connections, which was made possible by having a desktop app. We also added ROS2 support for both live connections and recorded back files. We've offered a few new panels like the map panel, the teleop panel, and we've added layout management and other collaboration workflows for your teams. And I think most excitingly, we've released our custom extensions API so that you don't have to be constrained by what we explicitly offer within the app. We provide all the tools that you need to tailor your Foxglove Studio environment to your project. And so going forward, we hope you'll help us determine the trajectory of our future development. Whether you're an open source user or part of a large enterprise, we would love to hear from you and hear your feedback. Cool. So now I will do a little demo. Let me share this video here. Cool. So Foxglove Studio is available as a web app and a desktop app. This demo here is using our desktop app, but just wanted to share that it is available on both these platforms. And so here we are in Foxglove Studio. We are in a layout with just a 3D panel. And 3D panels basically display a rich interactive 3D scene for you to understand your robot. The playback bar allows you to use controls to explore your data over time. And so you can do things like change the playback speed, seek, scrub through, loop playback, and see the timestamp that your current playback time is at. You can also click into any of the markers in the 3D scene and interact with it to learn more about each of the markers that you see visualized. And so you can click on a pose, you can click on LiDAR points, and kind of get some rich data about what went into displaying that marker. So we are still playing back. Next, if you want to kind of go into a different visualization workspace, you can go into our layouts and switch between what you want to see. You can select different data sources. There's multiple that you can choose from. We're going to choose a local bag file here to load the data that you want. And then finally, you can kind of configure each of these panels that you add to your layout to look however you want it to look, to help you best debug and visualize your data. So there we have some customized Velodyne points that we have displayed. And playing through, we can see that it looks a little bit different from what we had before. And so to kind of continue building out this layout, we can add panels to make our visualization debugging workflow a little bit more like rich. So we've added a raw messages panel here, which lets you see data sources, your data sources, topic messages and fields, and kind of drill down into each of these fields to see more information about each one. I can also add a plot panel, which kind of like the name suggests, allows you to plot numeric values across time. And so let's say I want to plot this rate value here in the radar tracks topic. I can drill down into that topic's message field and see the numeric value charted over the time range of my loaded bag. I can also add plots, this time plotting the acceleration, and kind of see my bag play back through those numeric values. I can also add an image panel, which displays camera feed images from your data source. And so you can kind of select the topic that you want to visualize, and it'll show up in your layout as well. You can always kind of adjust these different panels in your layout so that it's kind of convenient for you to kind of see all this data in one view. Let's say we want to go into now a little bit more complex ways to investigate your data. Let's say I want to filter, the messages in my tracks topic to filter for a particular value. So for example, in this case, I want to look through my radar tracks and find the one where the field number equals a certain value. So in this case, 40. We have something called message path syntax that allows us to filter in this way. And so you'll see that with that, our plot has changed and is now plotting a different set of track values. I can zoom in horizontally and vertically to see kind of the full view of my plotted data. And lastly, you can kind of go into this variable sidebar here to add global values for your layout. And these are editable values. You can name them. I can call this one my track number and set it to a value that I determine. And then from there, I can use this value in any of my panels. So for example, I can go back to my plot panel and replace my hard-coded 40 with my global variable. And you'll see that as I change the global value, my plot also changes accordingly to plot that specific track's rate and acceleration. We can go into the raw messages panel as well and do the same thing. Let's say I want to just see the message for that radar track number 40. I can use message path syntax to play through and see messages that kind of correspond to that value. And lastly, I wanted to point out that we have extensions, and this is where you can kind of design your own panels that you can design to fit your project-specific workflow. And this is also something that our desktop app has unlocked, this ability to design and load your custom panels into your local studio environment. Cool.
Thanks, Esther. That was awesome. Just going to jump back over to the slides. Cool. So hope you enjoyed the demo. Before we jump into Q&A, I just wanted to briefly call out a few items on our roadmap. One of the big things we're working on right now is better support for UIDF models, robot models in the 3D panel. So we do support marker messages in the 3D panel, and we also recently added support for mesh markers. So you can generate your own markers and display them in the 3D panel, just like you can do in RViz. But one thing that we do not support right now and that we're working on is visualizing UIDF models in the 3D panel and hooking those up to your transforms. So if you have anything like a robot arm, that's obviously something to look forward to. Other things that we are working on are on our roadmap, more flexible plotting features. So our plots are pretty good right now, as Esther demonstrated. You can hook them up and do all sorts of types of visualizations there, but there's always room for improvement. More ROS message types. There's a lot of message types that we support natively today, but we want to always add more. If there are certain things that you're interested in, please jump in our GitHub, check the issues list, search if it's already mentioned. It always helps to upvote or add a comment. Custom data sources. So as Esther mentioned, we have support for ROS1 and ROS2 today. We have some additional data connections, but we want to make it easy for someone to write a new data source connector and then package that up as an extension. Our extensions right now, you can create a custom panel with an extension, but you cannot create a custom data source connector with an extension. Although the app is open source, so you can always kind of fork it and do whatever you like, but we really want to make it easy for you to create extensions and then just load those extensions at runtime rather than having to build the whole app. Finally, cross-browser compatibility. So our desktop app you can download for Mac, Windows, and Linux, but our web app currently requires Chrome or Edge browsers. This is because we use a bunch of bleeding edge features, so we definitely want to add support for Firefox and Safari. If there's anything else you want, definitely let us know. Jump on our GitHub. Feel free to open an issue there or search or upvote or comment on existing ones, or join our community Slack channel. Finally, so just a quick mention that we launched a new product this week, the Foxglove Data Platform. In this talk, we're focused mostly on visualization, but I feel it's equally important for developer productivity to have a well-organized place where you can store all of your robotics data. And robotics data takes up a lot of space. So most of the teams I talk to are either passing hard drives full of bag files around the office, or some people have a shared NAS or Amazon S3 where they just store their bag files. But this is really inefficient. It means that you need to download a huge file to your laptop or desktop, even if you're only interested in a few seconds of data, or if you only need certain topics from that file. So as Esther mentioned, we really want to make sharing robotics data as easy as clicking a link. And Foxglove Studio you can always use locally. It's always going to be open source and there for your local data. But we want to make this workflow better for larger companies. And so that's what our data platform does. It lets you securely upload and store your bag files in the cloud, where we partition and index them by topic. So that means we break down the bag files, we store all of the topics separately, and that allows us to provide really fast streaming access to your data, whether that's from Foxglove Studio or a Jupyter notebook, or even generating a bag file on demand with only the topics you need for playback locally. So if you're interested in trying that out, please sign up on our website or feel free to reach out to us with any questions. And now we can jump into the Q&A.
Great, thank you, Adrian and Esther. If you want to stop sharing, you can see you bigger, or the stream can at least. We got lots of questions here. That's great. Starting off with, you talked about the extension points. How can you group them or share what capabilities are available as extension points and APIs?
Yeah. So this is something that we are, the extension API we launched a few months ago. Right now, you can create a custom panel. So Esther demonstrated all of the various built-in panels that we have. Right now, you can create a custom panel. You can create a custom panel either with just plain vanilla HTML and JavaScript, or you can use something like React or WebGL, or if you want to get more advanced with it. And so that's the main thing that you can do with extensions today is create a custom panel type, and then you can load those. One thing I'll mention with extensions is we do have kind of like an extension registry where you can publish your extension and then it'll make it available for other people. So if you're interested in building kind of an extension that you think is useful, you want to open source that, you can publish it, that's fine. You can also, you don't have to do that, right? So if a lot of companies that we work with already have custom private extensions that are pretty specific to their needs. And so, you know, if Foxglove gets you 90% of the way there, but the last 10% is sort of something particular custom, you want some custom panel to control your robot, you can bundle that up as an extension and just use it within your company.
Cool. So we got one question is, why shouldn't I ditch RViz for Foxglove ASAP?
Yeah, exactly. That's a great question. Give it a try. Let us know if you have any feedback. If I would say that there are some things that RViz can do today. It's been around a lot longer, so there's some things that you can do in RViz that you cannot do in Foxglove. Especially the thing I mentioned around URDF models is something that we're working on. But otherwise, certainly at Cruise and other self-driving car companies, I know that this is in use exclusively, and there's no one using RViz. So give it a try. If there's anything that you feel is missing, please let us know.
So there's several questions related to that. Do you have support for interactive markers?
Interactive markers. Yeah, so there's a lot of different things you can do with markers, I guess, and it might be worth us sharing a link to the docs in the chat. But we support two types of, we have image markers and we have 3D panel markers. So in the image panel, you can overlay things like bounding boxes or classifications. In the 3D panel, you can do all the 3D markers that are supported by RViz. We do have support for mesh markers. We do allow you to actually sort of click on markers, and you can click on a marker to inspect its properties, or you can, there's a lot of things that you can do there. We also have support for rendering things like transforms directly, so you don't sort of need markers specifically for that. But yeah, if there's anything else that you are missing, please let us know.
So there's a question about what is the underlying technology? Is it straight web technology, or is it somehow using existing tools under the hood?
No existing tools. So this is all written on the web stack with a slight caveat. So we have not recompiled RViz or anything to run in your browser. It's all written in mostly in TypeScript with some WebAssembly thrown in the mix and WebGL. Our desktop app is built on a technology called Electron, which gets a lot of hate, but it's actually a really awesome technology. This allows us to run a web stack as a desktop app, which means that you get a nice shortcut to it. And it also allows us to do a few things where we can run native code on your computer. So when you run the desktop version of Foxglove Studio, we give you a few additional features. You get the ability to, when you run the desktop version of Foxglove Studio, we can do things like we can open TCP connections and UDP connections. So that allows us to connect natively to a running ROS system. Whereas in the browser version of Foxglove Studio, the browsers let us load files locally, for example. They allow us to connect over a WebSocket connection using ROS Bridge WebSocket connection, but we cannot just sort of like make a TCP connection from the browser. So yeah, that's basically it. Most of it's written in web technology. If you use the desktop version of that, there is some native code running alongside that, but no existing tools were kind of used.
Great. So it's a little bit different. Asking about the Foxglove data platform, are you familiar with the Ternaris Marv robotics and Swery bag databases? If so,
yes.
Can you compare and contrast?
Yeah, I've looked at a few of these. I've never seen a large company using them. If you're out there and you're using something today and you love it, I would love to hear from you. But yeah, I've looked at a few of these products. Mostly they seem to revolve around uploading a bag file and then saving that bag file. We are sort of approaching the problem differently. We think that we should be sort of uploading robotics data, and the kind of concept of a bag file even is an abstraction that you shouldn't really have to be thinking about. You care about robots and topics and timestamps. So a lot of companies, for example, I talk to, record half a dozen different bag files. They've got their robot out there doing its thing, and they're recording one bag file for most of the topics, and then they're recording a different bag file for each of the cameras or lidars, maybe, because those are heavier weight. And so, you know, maybe you've got like 8 or 12 bag files, and then maybe you've also got some CSV data or something else. You're dumping a YAML file with some parameters, and all of this constitutes like what you recorded from your robot. And so I think that we want to upload this data and just say, okay, if robot X went on a trip Y, and here's the data that we have, here's the topics we have. If you want just a couple of those topics, like, let's download them, great. If you don't need all of the cameras and sensors because you're just looking at the controls stack or something, great, just download those topics or just visualize those topics. And then so we provide a CLI where you can just basically generate a bag file on demand. So that's kind of where I see us doing things differently. But like I say, if it's a space that you're interested, I would love to sit down and have a chat about it.
Cool. One last question is, do you have a Docker release?
We do. I would caveat this with, you should not need, okay, so I guess like I would need to distinguish between, are you talking about running the actual graphical version of the app inside Docker, which some people do. I'm not sure if that's possible today. I've not tried it. The other way you could be approaching that is running the web version, hosting your own version of the web app in a Docker container. We have a Docker container that will let you build the version of the web app and host it. So you're welcome to build that yourself and download it and run it as a Docker file just in the root of the repo that'll get you going there. I will say that it shouldn't be necessary. You can just go to studio.foxglove.dev, or you can go to foxglove.dev and click the big try it now button. And that app is running entirely in your browser. So if you can connect to a local robot running on your network, you can load a file that is on a remote source, or you can load a file straight off your desktop, and none of that is going over the internet or over the cloud. So yes, you can run Studio, the web version of Studio, in a Docker container. If you need that, I'd love to kind of, you know, we love to hear about these use cases. So jump in our Slack channel and let us know why. Otherwise, feel free to just use the hosted version of the app. And like I say, you can still connect to a data source that's behind your network because everything is running in your browser.
Cool. Well, Adrian and Esther, thank you very much.
Thank you.
Thank you.
If you wouldn't mind going into the swap card, there's a bunch more questions people asking there. You can just respond in the chat there. And also people definitely, you know how to reach Esther and Adrian, they put up their info. So reach out to them directly as well. We're on Slack.